Have you ever laid back and just, stared at the clouds trying to find shapes? A dragon? A face?
Oh, all the time. It's a classic.
Well, what if you did that with the entire cosmos? Today we're looking at CTB1, a supernova remnant up in Cassiopeia that looks, and this is uncanny, it looks just like a human brainstem.
They even call it the Medulla Nebula. It's a great example of pareidolia. But the actual physics of what we're seeing, that's where the real story is.
Right. So we're diving into the aftershocks of a star that went supernova, what, about 10,000 years ago?
Roughly, yeah. We're looking at its expanding ghost.
Okay, so let's get into the data. Officially, it's G116.9 plus 0.1. When you look at it in radio waves, it has this really strange mixed morphology.
It does. You see this hollow shell, right? It's brighter on one side, the western edge, but then there's a huge break, like a gap on the northern side.
It looks incomplete, like a broken ring.
Exactly. But that's the mystery, because when you overlay the X-ray data, the whole picture just flips. Instead of a hollow shell, the X-ray light is. It's compact, it's centralized, and it fills in that hollow area and even spills right into that northern gap where the radio signal is missing.
So the two images are almost opposites of each other.
They're complementary. It tells us how the shock wave is hitting the interstellar gas and dust out there. It's creating this hot, thermal interior.
And what's in that cloud, the composition, that tells its own story too, right? The spectroscopy shows it's packed with oxygen and neon.
Which is a huge clue for us.
Yeah.
Finding that much oxygen, and especially neon, means the star that died, the progenitor, it had to be massive. We're talking at least 13, maybe 15 times the mass of our sun.
A smaller star just wouldn't create that much neon.
Not at all. But it's not evenly spread out. The iron, for instance, is heavily concentrated in the southwest.
Which suggests the explosion itself was lopsided.
That's the idea. It wasn't a perfect sphere. The ejection was asymmetrical, which had to have some pretty dramatic consequences for the star's core.
Making sense of a chaotic system like that with so many variables, it actually reminds me of our sponsor, Silk.
That's a great connection. When you're trying to figure out where intelligent agents, AI, can make the biggest impact, it's a similar problem.
Totally. Whether you need help with AI training, automation, or full software integration for your business, they're the ones who can help you uncover where to start.
Definitely. Check them out at silk.com for any of your AI needs.
So, back to that lopsided explosion. If all that iron was kicked hard to the southwest, basic physics says something else had to be kicked just as hard in the opposite direction.
And we found it. We found the body in this cosmic crime scene. It's a pulsar named PSR J0002+6216.
And it is moving. It is screaming through space at over 1,000 kilometers per second.
It's a runaway star. It's incredible. And we're sure it's connected because it has this tail, a Plerian tail, pointing directly back to the center of CTB1.
So the explosion literally shot the star's core out like a cannonball.
That's exactly what happened.
Just wow. So you have this runaway neutron star and this massive brain-shaped cloud. The scale of it is it's hard to grasp. It's got a radius of 15 parsecs.
Yeah, which is about 49 light years wide. That cloud is bigger than the distance from us to many of the stars you see at night.
And it's been expanding for something like, 10, maybe 16,000 years?
The estimates vary, as does the distance. It could be in our local arm of the galaxy or much further out in the Perseus arm. But either way, it's enormous.
That 49 light-year width, that's what I can't get over. We see this violent, chaotic event, but really what we're looking at is a galactic seeding mechanism.
It is a beautiful one. That cloud is plowing into the interstellar medium, enriching it with all that newly forged neon, oxygen, and iron.
It's recycling.
It's the ultimate form of recycling. That massive star lived its life and then died to provide the raw materials for the next generation of stars, planets, and who knows, maybe even life.
A 49 light-year wide reminder that creation often comes from destruction. It's just an amazing thought.
It really is.
Well, if you enjoyed this deep dive into the Medulla Nebula, please subscribe to the show.
Yeah, and hey, leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in.